Hello everyone, my name is Aimée, Ogando, and I am going to be presenting my Physics 2211 Lab 2. These are the objectives of the lab. The problem that this lab intends to answer is what are the differences between a computational model of the velocity of a fallen object that takes into account drag and gravitational force and one that only takes into account gravitational force. My hypothesis for this problem is that the model that takes into account the effects of drag and gravitational force will resemble more closely the observational model than the model that ignores drag because it will take into account more forces that are applying the movement. The fundamental physical principle involved in this problem is Newton's second law, which is also considered as the law of motion because it describes the behavior of objects for which all forces are imbalanced. It tells us that the net force of an object is equal to the mass times the acceleration, where net force and acceleration are vectors. This ultimately translates to the change in momentum vector being equal to the net force vector times the change in time. As well, this experiment takes into account the drag force, also known as air resistance or friction force, and it is the force acting opposite to the relative motion of the system. This force can be found by multiplying the negative proportionality constant by the squares of speed of the object and the velocity direction. The gravitational force is the force by which the mass of planets or objects are attracted to each other. This is found by multiplying the negative gravity of the system times the mass in the direction of the gravity. These are the variables and materials used in this experiment, and this is the procedure followed to do this lab. This is the video of the experiment where you can see a wet bandana falling towards the floor. From the video, I extracted information about the change in position through time and created a graph and table. We can see that the experiment began approximately at time 0 in position 0 and ended at time 0.5 seconds at position negative 1.651 meters. In this experiment, the change in position shown only takes into account the vertical movement of the object. From the time frames and information taken, a graph was plotted. This graph does not show a perfectly linear velocity where the velocity is the slope of the line shown. To attest my knowledge on Newton's second law, I created a computational model using GlowScript, where I insert in values of the mass of the object, the duration of the movement, the gravitational force acting on the system, and the position of the object to predict motion of the object using this principle. This graph shows a much more curved velocity than the last one because it takes into account the gravitational force acting on the system. As well, I created another computational model where I added the value of the drag force acting on the object to resemble more the actual movement. To calculate the proportionality constant, I just ran multiple times the code until I received similar values to that in the observed motion. This graph shows a curve similar to the last one, but we can note that towards the end, its velocity is much less curved and more flattened out. In order to compare my observed movement with the predicted movements, I decided to graph the three lines under the same plot. Here we can see how much the predicted movement with drag force resembles the observed movement and the difference between these two models and the model that ignores drag force but takes into account gravitational force. As well, in this graph we can see how the model that takes into account drag force starts to flatten out towards the end, while the other model stays curved throughout the whole movement. These graphs prove my hypothesis was correct. The model that considers drag and gravitational force resembles more the starting or the observed motion than the model that only takes into account the gravitational force. Highlighting the most important parts of the computational model without drag force, we see that the initial position of the object is 0,0,0 and the velocity is negative 0.2827 meters per second. In order to predict the final position of the object in time, I used a while loop to calculate the change in position until time is less than 0.5, which is after the movement goes out of the frame of the video. For this experiment, I assumed that the net force acting on the object is only the gravitational force. To predict the final velocity and the final position in each time frame, I used the Newton's second law. The only difference between this model and the model that considers drag force is the added value of the proportionality constant and the net force, that is the sum of the drag and gravitational force. After ending the experiment, we can say that the observed motion resembles the predicted motion with drag force more closely, while the predicted motion without drag force estimates motion above the other two models. This is so because the drag force adds another factor that the system actually experiences rather than ignoring it, showing greater fidelity to reality. As well, we conclude that we can use Newton's second law to predict an object's motion when the net force is not equal to 0, considering more than one force is acting on the object. I would like to note that this experiment did not take into account marginal errors like the cross-directional wind in the x-axis and may have some systematic errors like the use of only 15 time frames. Analyzing what model predicts better the terminal velocity allows us to conclude that it is the model that includes the drag force. Through the graph, we can see that towards the end of the movement, velocity starts to flat out, different from the curve seen earlier in the movement. And if we ask ourselves, what if the object was thrown downward, we would respond that the terminal velocity would not change because towards the end of the movement, both movements start to flatten out, showing approximately the same terminal velocity. This is so because both forces depend on the properties of the objects rather than other factors acting on the movement system. Calculating the terminal velocity, we can see that in the end, it only depends on the proportionality constant, gravity, and mass of the object. Thank you for your attention.